In this video we'll be making methylamine hydrochloride by reacting ammonium chloride and formaldehyde solution. This is a well-established procedure that you can read upon, but we've made a few minor tweaks. Set up a liter flask with stirrer and thermometer. First, weigh out 230 grams of ammonium chloride crystals. Using a funnel, pour these into the reaction flask. Now weigh out 460 grams of 37% formaldehyde solution in water. This should be around 410 ml of liquid. Add this through the funnel to the ammonium chloride in the flask, and once added, begin stirring. At this stage, not all the crystals will dissolve. Set up the flask for simple distillation. The thermometer immersed in the liquid is important, but we don't need to measure the temperature of the distillate, so I've used a simple bent glass adapter. The receiving adapter and flask are set up so that we can apply a vacuum later on when we want to. Heat the flask. Due to the volume of liquid, you'll need quite a strong heat, but don't go too hard. At around 60 degrees C, all of the crystals will dissolve. Distillation commences at just over 90 degrees C. A reaction kicks in and the liquid boils, and the temperature rapidly increases to 108 degrees. Make sure the water going through your condenser is quite cold, because a lot of distillate will rapidly come over. Soon the reaction dies down, and you'll see tiny bubbles of carbon dioxide being formed in the liquid. This is a reaction taking place. At this point, control the temperature carefully and adjust the hot plate so that the flask is a stable 104 degrees C. Play around for 30 minutes or so in order to get this correct. Now leave the reaction going, and at the constant 104 degrees temperature for 3 hours. After this time, the flask will still be bubbling slightly like this. Next, we hook up vacuum pump and carefully distill the mixture further. Be careful not to boil over initially, and you'll find that you'll need to turn up the heat to compensate for the additional boiling in order to keep the temperature at the constant 104 degrees C. After a further 2 hours, more distillate will have condensed, and the reaction mixture will have reached saturation point as crystals will form in the solution. Chill the mixture, and then filter the crystals off using a vacuum pump. Reserve both the filtrate and the crystals. Get the crystals as dry as you can. In theory, this is unreacted ammonium chloride, but keep them just in case. The filtrate is around 250 ml of solution containing our product. It may also contain a small amount of dimethylamine and some more ammonium chloride. Place the filtrate into a flask equipped with a thermometer, and set up again for vacuum distillation. This time we're using a smaller flask and a stronger heat source. Now we need to get as much water as possible out of the mixture. You can do this in a beaker over a strong heat, but distilling is a lot less messy, and using a vacuum makes it go quickly. Depending on how good your vacuum is, you will start to see water distilling at between 80 and 110 degrees C. The temperature will slowly rise until you see a white smoke in the flask, which is our product evaporating. In this case, this occurred at 160 degrees C. At this point, switch off the heat and allow to cool slightly to around 150 degrees. Then, pour the amber-colored liquid remaining in the flask into a beaker. As you pour in the liquid, you should it crystallizing immediately as it cools. This is our crude methylamine hydrochloride product. Stir it, then cover with a sheet of polyethylene wrap to prevent it from absorbing moisture from the atmosphere, and allow to cool. Prepare 200 ml of hot ethanol, and first use this to wash out the flask, then add this to the beaker containing the crystalline crude product, and stir to break up any lumps. The theory here is that methylamine hydrochloride is soluble in ethanol, whereas ammonium chloride is not. Filter the resulting slurry, get the crystals dry, and then wash the filtered crystals with a further 3 batches of 50 milliliters of warm ethanol in order to get all of the methylamine hydrochloride out and into the filtrate liquid. As the filtrate cools, you'll see crystals separating out of solution. Once you've got all the ethanol filtrate, chill this down to below 10 degrees in order to precipitate as much as possible. In the meantime, you'll be left with some more white ammonium chloride crystals in the filter, which can be reused. In this run we obtained a further 35 grams. The chilled filtrate containing the methylamine hydrochloride crystals was then refiltered to obtain the white solid on the left, and the alcoholic amber filtrate on the right. We dealt with the crystals first, and macerated them with 50 milliliters of chloroform in order to dissolve out any dimethylamine. The crystals were then filtered again, washed with an extra 25 milliliters of chloroform, then quickly dried to a reasonable state, and placed back in an airtight container. This was then hooked up to a vacuum pump to draw off any remaining chloroform on the crystals. The alcoholic filtrate was distilled until only about 50 milliliters of a syrupy liquid remained in the flask. This was then cooled, and crystallized into a slush rapidly. This was filtered, and as before, the crystals washed with chloroform. So in the end we got 2 batches of product, around 80 grams of crystals on the left, which were from cooling the ethanol solution, and about 15 grams on the right, from boiling down the filtrate and crystallizing. Our conclusion was that the additional boiling down step was not worth the effort given the high yield from the first batch of crystals.